a quick review of that in today's session. Once again, good morning, everybody. In the previous class, we looked into a series DC series circuits. What are the characteristics of the DC series circuits? And we also solved a few problems based on the DC series circuit. Okay, this was the problem. What is the answer for this? Maybe you can put it in the chat section. I is equal to 0.035. Any other answers? I hope everybody understood the concept here. Okay, I is equal to 0.035. Athiya and Vaishnavi has got the same answer. Okay, so just quickly we will review the concept here. These are the multiple EMF sources are present. When multiple EMF sources are present, and if there are resistors which are connected in a very complex manner where you will not understand whether it is a series or parallel, those are called as a complex circuits, and those circuits are solved using the Kirchhoff's laws. Okay, this one is, even though it looks like a complex, it is not really complex. Only one current will be flowing through the circuit. That is the reason we can say this resistor and this resistor are in series, and these two EMF sources, they are trying to send current in the opposite direction. That is how the effective voltage EMF of this particular circuit will be 22 minus 15. I told either the two EMF sources can add together, means they can complement each other, or they can be in the reverse direction where they will, the net EMF will be the difference of their EMF. So 22 minus 15 volt. And which direction the current would be flowing? Current would be flowing in this direction, because 22 volt is higher potential compared to 15 volt. And total resistor of the circuit is 47 plus 150. That is the 150. So we converted this particular circuit into simple circuit where we have one effective resistance, which is sum of the individual resistance, and one EMF source, which is a difference of their potential, 22 minus 15. So that is how it becomes. Okay, the question, your answer is correct. Both of you answered correctly. The current is 0.0355. What the question was asked is, what is the EMF across, what is the voltage drop across the 150 ohm resistor? Once you know what is the current that is flowing here, that is 0.035, the same amount of current will flow through 47 ohm resistor as well as 150 ohm resistor. If you apply Ohm's law here, V1 is equal to I into R, and I is 0.035 amperes into 150 ohm. That will come as 5.325 volts. Okay. So this is RS is 197 volt, 47 plus 150 ohms. VE is 22 minus 15 volts. That will be resulting is 7 volt. Effectively, the circuit is, there is a one resistor, 197 ohms. It is connected to 7 volt EMF source. Therefore, the current is equal to, according to Ohm's law, I is equal to VE by RS, that is 7 by 197. You get it a current as 0.0355 amperes. And voltage across 150 ohm resistor, the same current will be flowing through both the resistor. So, according to Ohm's law, V is equal to I into R, 0.0355 into 150. You get the voltage across 150 ohm resistor is 5.325 volts. If there are any questions based on the DC series circuit, you can ask, or you can put it in the chat section. Okay, good. Okay, next we will continue with the DC parallel circuit. And in case of a series circuit, we did the, what are the different characteristics, how to identify whether the resistors are connected in series, that we understood. In case of a parallel circuit, we will understand first what is the meaning of the parallel circuit. So if the resistors are connected between two common points or common nodes, then we call it as a parallel circuit. For example, we have a common node here. This is one common node and this is one another common node. Each of these resistors R1, R2 and R3, they are connected between two common points or common nodes, and those nodes are connected to the EMF source with the conductor. So if resistors are connected between two common points, then we call it as they are in parallel. Okay, so when one end of each resistance is joined to a common point and the other end of each resistance is joined to another common point, so that there are as many paths for the current to flow as the number of resistances, it is called as a parallel circuit. That is the definition. So if we have resistors connected between two common points, then what happens, the current has those many paths, those many are number of resistors which are connected in parallel. Suppose if I have three resistors in connected in parallel, current will have three paths. You can just assume this like a you have a pipe here, and that pipe is joined with like a three other smaller pipes. Okay, and the whatever the water that is flowing in the main pipe will get distributed into the three different pipes. And how much current will get distributed into each of these pipes, it depends on the size. Okay, in case of a like if it is a larger pipe, the amount of current will be flowing in that pipe would be more. If the diameter of the pipe is less, then the amount of current will be flowing would be less. Okay, so the meaning is, if the pipe diameter is more, the amount of resistance it offers for the flow of water is less, so more water will flow there. And if the diameter of the pipe is smaller, it will offer more resistance to the flow of the water through that particular pipe, so it will result in less current. It's exactly similar to that. This is the total current. When we connect the voltage source across this parallel branch, the total current I will flow here. The minute it comes to the common point, it will be divided into the parts, different parts, and those currents would be exactly same as the whatever is the total current. So at this point, I can say whatever the total current I is equal to the sum of the individual branch currents. That is, I is equal to I1 plus I2 plus I3. Whatever the current that is flowing, the main current will be distributed into the branch currents. So that is why we can say the main current or the total current of the circuit is equal to sum of the individual branch currents, or in terms of the equation, I is equal to I1 plus I2 plus I3. Now next question is, how much current will flow through the resistor R1, how much will flow through R2, and how much will flow through R3? The amount of current that will be flowing in particular branch is dependent on the resistance. If resistance is high, the amount of current flowing will be more or less. If resistance is more, the amount of current that will flow in that particular path would be more or less.
Less.
Less, because
Yes.
the resistance is more, the current will be reduced. And any path where there is a resistance is less, a large amount of current will flow through that particular branch. So that is how this will get divided. And once it comes to the another node, so from this branch I1 current will come, from this branch I2 will come, from this branch I3 will come. Again it will add together, that is I1 plus I2 plus I3. And when it comes back to the EMF this side, the amount of current would be same as this I. For example, if consider the amount of current that is flowing is 10 amperes. 10 amperes will come here, and let us say it will get divided like 1 ampere will flow here, 3 ampere will flow here, 6 ampere will flow here. 1 ampere is flowing here means resistance R1 is greater than resistance R2, because 3 amperes is flowing here and 6 amperes is flowing here. That is, R3 is the least among the three resistors. Those currents will add together, 1 plus 3 plus 6. Again, it will come back as a 10 ampere. And similar to the resistors which are connected in series, we can replace this combination of this parallel resistor with one effective resistor. So what is this effective resistor? This effective resistor, if you replace this combination with this effective resistor, and if it is connected to the same voltage source, it will result in the same amount of current. That is called, we can call it as a effective or equivalent resistance for this combination of resistors which are connected in series. We will understand how we can find out that particular effective or the equivalent resistance. From Ohm's law, we can apply it to individual branch. Wherever you see the resistor, you can apply the Ohm's law. I can apply the Ohm's law here, I can apply the Ohm's law here, and I can apply the Ohm's law here. Here, the amount of current flowing will get divided into all the branches. And the between these 2 points, how much is voltage is applied? The amount of voltage applied is nothing but V. So these are the conductors. Whatever the line you see, those are the conductors. We assume that they will not have any resistance. Whatever is the potential here across the positive and negative, that would be the same potential across these two common points. If this is 50 volt, then between this node and this node, 50 volt potential will be there. What is the meaning of that? These two are the common point. So the voltage across each of this resistor would be V. What is the resistor across R1? It would be V. What is the resistor? What is the voltage across R2? It would be V. So whenever we have resistors connected in parallel and when they are applied across a voltage, the voltage is common or the same across all the resistors. So we are going to apply the Ohm's law here. So if what is the voltage across this resistor? V. V is equal to I1 into R2. If I apply Ohm's law to the second branch, V is equal to I2 into R2. And the last branch, V is equal to I3 into R3. So by Ohm's law, we can see I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. So you have to observe here, the voltage across each of the resistor is exactly the same, V. And we also know that the total current that is flowing in the circuit will get divided into all the branches, so that we can say that the total current that flows in a circuit is equal to sum of the individual branch currents. That's why we can write I is equal to I1 plus I2 plus I3. And what is I1 from this? V by R1, I2 is V by R2, I3 is V by R3. So that V is common, V is equal to, I is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation. If I take V on the other side, I get I divided by V. Now, the second circuit diagram, I told this is the equivalent circuit diagram. What is the meaning of the circuit diagram? Let us say 50, I am applying with R1, R2, R3, I am applying 50 volt and it is resulting in 10 ampere. I will take another circuit. This is 50 volt. I will choose the value of RP in such a way that 10 amperes will flow. Then I will say RP is the equivalent of this circuit. Both the circuits are equivalent circuit. And for this circuit in figure 2, if I apply the Ohm's law, V is equal to I into RP. That is the Ohm's law. V is equal to I into RP, or 1 divided by RP is equal to I divided by V. That is the second equation. Now, from the first equation, we got I by V is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Second equation, I by V is equal to 1 by RP. If I substitute this second equation in this, that is, if I replace the value of I by V with 1 by RP, the equation I get is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is the meaning of this? The equivalent resistance can be calculated using this formula. So how you define this particular equation? The reciprocal of the equivalent resistance is equal to sum of the reciprocals of the individual branch resistances. You have to be very, very careful when you are solving the problems based on the parallel circuits. It is always 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I will tell you the most common mistake that everybody does is they start with the 1 by Rp. Let us say they have a given one circuit. There are three resistors with resistances 5 ohm, 10 ohm, and 20 ohm. If I ask you to calculate the equivalent resistance of that particular combination, then you start with 1 by Rp is equal to 1 by 5 ohm plus 1 by 10 ohm plus 1 by 20 ohm, right? Then you left hand side you will keep it as 1 by Rp, and you will start calculating equals to, and you keep on calculating. At the end you get some value. What most of the students make a mistake is, at the end whatever the value they get, they will say Rp is equal to that value, which is uh, wrong. What should be that 1 by Rp is equal to that value. You have to remember. Otherwise what you can do is always write 1 by Rp, 1 by Rp at every step. Write 1 by Rp so that you won't miss. If you make that mistake, actually instead of taking the actual resistance, you will be taking the reciprocal of the equivalent resistance. Now we will look into the different features of a parallel circuit. Okay, so already we discussed a few of the characteristics or the features of the parallel circuit. We'll look into the other. The first one, the voltage across each resistor is the same. If we have 10 resistors connected between 2 points, then the voltage across all the 10 resistors would be exactly the same. In case of a series circuit, current through all the resistor is the same. In case of a parallel circuit, voltage across all the resistor is the exactly the same. The current through any resistor is inversely proportional to its resistance. Meaning what? The current that is flowing in each of these parts or the each of these resistors is inversely proportional to its resistance. If the resistance of the particular path is more, then the amount of current would be flowing in that particular branch or the path would be less. If the resistance of the particular branch is less, then the amount of current flowing in that particular branch would be more. The total current in the circuit is equal to sum of all the parallel branch currents. That is, I is equal to I1 plus I2 plus I3, where I is the total current, I1, I2, I3 are the branch currents. The reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. That is, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. If you have n number of resistors plus 1 by Rn, so on. Okay. So always remember, it is the reciprocal of the resistance, total resistance, that is 1 by Rp. Don't make a mistake. It is always a reciprocal of the equivalent resistance is equal to sum of the reciprocals of the individual resistances. As the number of parallel branches is increased, the total resistance of the circuit is decreased. Okay, as the number of branches start increasing, the amount of resistance that would be offered by that particular combination will reduce. Just to give an example, if I say like there are two resistors which are connected in parallel, and each of their value is 3 ohm and 3 ohm. Can you find out the what is the equivalent resistance? Two resistors that are connected in parallel and both's value is 3 ohm. What would be the equivalent resistance of that particular circuit? What is the value of Rp?
3.
3,
No,
sir.
there are
3. 3 ohm.
is it 3 ohm? Anybody? There are only two
1,
resistors which are connected in parallel.
1.3.
1 point
3 by 2.
3 by 2, 1.5 means 1 by Rp is equal to 1 by 3 plus 1 by 3, isn't it? So 1 by 3 plus 1 by 3 is 2 by 3, and this is reciprocal. So if I take the reciprocal, Rp becomes 3 by 2. Rohit, correct. Okay, 1.5 ohm. Now what the characteristic says is, one of the features is, if you add more branch, the resistance of the circuit will decrease. Now you take the same circuit, 3 ohm is there, 3 already, 2 3 ohm resistors are there. Connect one more 3 ohm resistor and tell me what is the effective or the equivalent resistance Rp. Now there are 3. I have increased one branch and its resistance is also 3 ohm. What is the
One,
equivalent? Hmm?
one,
1.
one,
1 ohm,
one.
right? Okay, when you are keep on increasing the earlier, when we had only 2 resistors in parallel, the Rp value was 1.5. When I added one more branch with 3 ohm, the effective resistance became 1 ohm, because 1 by Rp is equal to 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3, that will be 1 by 1. So reciprocal of that is Rp is equal to 1 ohm. So that is the meaning of this. As the number of parallel branches is increased, the total resistance, that is Rp, will be decreased. The total resistance of the circuit is always less than the smallest of the resistances. So if you have like uh, let us say, I will take one more example. I have a 3 resistors in parallel, 10 and 5 and 2 ohms. You can, without looking at the, without doing any calculation, you can tell that Rp would be less than 2 ohm. Can you calculate that? Now there are 3 resistances, 10 ohm, 5 ohm and 2 ohm. What would be the effective resistance Rp? 1 by Rp is equal to 1 by 10 plus 1 by 5 plus 1 by 2.
0.8.
0.8. See, I'm not sure whether it is correct or not. Anybody else, can you confirm?
0.8.
0.8. Very good. So
0.8.
okay. Now these characteristics helps you in verifying whether your answer is correct. So this feature, what it says, the total resistance of the circuit is always less than the smallest of the resistances. You have 10 ohm, 5 ohm and 2 ohm. Without doing any calculation, you can understand the effective resistance will come as less than the 2 ohm. Let us say you made some mistake in calculation and you are getting it as 3.5 ohm. So straight away you will know it is incorrect, because it has to be less than the 2 ohm. So you can take n number of circuits. Okay, now if you have like a 10 5, 2 is there, add one more 1 ohm, the effective resistance would be definitely less than 1 ohm. That is how we can use this particular characteristic. Next one, if n resistors of resistance are connected in parallel, then total resistance Rp is equal to R divided by N, where N is the number of resistors and R is the resistance value. The same earlier example, what you did was, like, there were 3 resistors, each resistance is 3 ohm, they are connected in parallel. 3 ohm is the resistor. How many branches are there? 1 2 3. One way is you can calculate 1 by Rp is equal to 1 by 3 plus 1 by 3 plus 1 by 3. That is how you can calculate. If the resistance values are exactly the same, then you need not do that way. You can use this particular formula. Rp is equal to R by N. What is the, in our example, what is the value of R? 3. How many resistors are there? 3. 3 divided by 3, 1 ohm. And you have to make sure that all the resistances are equal, then only you can use this formula. Otherwise you cannot use. Let us say you have 4 resistors connected in parallel. The value of first one is 5 ohm, second one is 5 ohm, third one is 5 ohm, the fourth one is 3 ohm. Then you cannot use this formula. Okay, all the resistors which are connected in parallel must have the same resistance value, then you can use this particular formula. The conductances are additive. So conductance is one, reciprocal of resistance is nothing but the conductance. those are additive because 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if you write it in terms of conductances, then G is equal to G1 plus G2 plus G3. Then next one is the total power dissipated in the circuit is equal to sum of the powers dissipated in the individual resistances. So if you consider this parallel circuit, if you consider this parallel circuit, if if you are asked to calculate how much power is consumed or dissipated in this particular circuit, the total power dissipated in this particular circuit is equal to sum of the powers dissipated in individual branches. And this definition, this feature also goes similar in the series circuit. What is the total power dissipated in the series circuit? It is the total power, it is sum of the powers that is dissipated in the individual resistors. It is exactly the same. How to prove that? We know the formula for the equivalent resistance. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Let us on the both right hand side and the left hand side, we multiply it by the V square. And what is the V? V is nothing but the applied voltage. If we multiply both the sides with the V square, what we get is V square by Rp is equal to V square by R1 plus V square by R2 plus V square by R3. And we know that power can be represented in three different forms. First is P is equal to V into I, or P is equal to I square into R, or power P is equal to V
V
square
square
by
by R.
R. Correct? So with that definition, V square by RP is the total resistance. V square by RP is nothing but the total power dissipated or consumed in the circuit. That is equal to V square by R1 is the power dissipated in the resistor R1, that is P1, plus this is the power dissipated in the second resistor R2, V square by R2, that is P2. Then V square by R3 is the power dissipated in the third resistor. That is how you can say the total power dissipated P is equal to P1 plus P2 plus P3. Any questions? Okay, so we'll solve one problem. All of you note down the problem. Two coils connected in series have a resistance of 18 ohm, and when connected in parallel have a resistance of 4 ohm. Find the value of each resistance. In the exam, they may not give you the circuit diagram. They will just give the description of the problem. So what is the problem? We have two coils. Don't worry whether they say it as a coil, lamp, bulb, anything. Everything in case of a DC circuit is nothing but a resistors. Two coils means you just assume that two resistors are connected in series, have a resistance of 18 ohm. They have not given the individual resistances, so assume the resistances as R1 and R2. So R1 and R2, when they are connected in series, their resistance is 18 ohm, and when they are connected in parallel, okay, when they are the same two resistances R1 and R2, when they are connected in parallel, their resistance becomes 4 ohm. What you have to do is find the value of each resistances. Can you do it? How many unknowns are here? How many unknowns are here in this problem?
Sir, in series resistance 9 ohms, sir. Unknown resistance.
No, you have to find what is the value of R1 and R2. So there are two unknowns, register R1 and register R2. Those are the two unknowns. What they have given is one thing they have given is the series combination. If you don't know the value of R1 and R2, but if you connect them in series like this, what would be the total resistance? Rs, that is R1 plus R2 would be equal to 18 ohm. That is what they have given. And when you connect them in parallel, if you connect them like this, the total resistance is 4 ohm. This is nothing but the Rp. They have given Rs and Rp. they are asking you to calculate R1 and R2. So what is the first equation just I told? With this particular circuit, what is the equation you get? Hmm? When two resistors are in series, RS is
R1
equal to
plus R2. R1 plus
RS is equal
R2.
to R1 plus R2.
Yeah.
RS they have given 18 ohm, isn't it? So first equation is RS is equal to R1 plus R2. RS is given 18 ohm is equal to R1 plus R2, or you can say R1 plus R2 is equal to 18. That is the first equation. Can you tell me the second equation when they are connected in parallel?
1 by R1 plus 1 by R2 is equals to 4 ohm.
Correct.
RP is equal to R1 R2 divided by R1 plus R2.
Yes, you can put it in that way, or you can say one. The simple thing is 1 by Rp is equal to 1 by R1 plus 1 by R2. And what is the Rp value? It is 4 ohm. So 1 by 4 is equal to 1 by R1 plus 1 by R2, or you can say 1 by R1 plus 1 by R2 is equal to 1 by 4 ohm. Now you got the second equation. You have to solve the second equation. Okay. And as once you simplify that, you will get the answer for the R1 and R2. Now can you solve it? Did everybody understood the second equation? Okay, let me come up to this. See, when connected in series, when two resistors are connected in series, their effective resistance is given as 18 ohm. So first equation comes as R1 plus R2 is equal to 18 ohm. When they are connected in parallel, what is the effective resistance? They have given it as 4 ohm. Therefore, 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by 4 is equal to 1 by R1 plus 1 by R2. Now 1 by 4 is equal to R1 plus R2 divided by R1 into R2, or R1 R2. If I take this on this side and this denominator on the right hand side, R1 R2 is equal to 4 into R1 plus R2. What is R1 plus R2? It is already given here. R1 plus R2 is equal to 18. If you replace that 18 value, 4 into 18 is equal to 72. This is the second equation. R1 R2 is equal to 2. R1 plus R2 is equal to 18. There are two equations. Now how to solve this? Now can you solve it? There are two equations. R1 plus R2 is equal to 18. R1 into R2 is equal to 18. R1 into R2 is equal to 72. Sorry. How to solve this? Anybody? Okay, somebody has. Okay. Srujana has already. This is correct. R1 is equal to 12 and R2 is equal to 6. Actually, you can convert this equation. You can write either in terms of R1 or either in terms of R2. Let us say you say R2 is equal to 72 by R1. R2 you will replace here 72 by 18. It will become R1 square plus 72 is equal to 18 R1. So R1 will have two values. This is how it will come. Replacing R2 is equal to 72 by R1. If you replace that in this particular equation, R1 plus 72 by R1 is equal to 18, or it becomes, if you simplify this one, it becomes R1 square minus 18 R1 plus 72 is equal to 0. This is nothing but a quadratic equation of the form ax square plus bx plus c is equal to 0. A value is a is equal to 1, b is minus 18, and c is 72. So this is the equation. Devika, can you recalculate and see whether you get Giridhar same? Can you just try whether you got it? Any mistake you did? No, Devika, the total resistance is 18 ohm. when they are connected in series, it is 18. Okay, if it is not clearly visible, that is okay, here it is 18. If it is okay, it might be little the scanning problem, it is actually 18 ohm. That is what I said, 18 ohm. Now if you calculate r1 is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. That is how you find the roots of a quadratic equation. You substitute the value of a, b and c and in this particular equation, and you will get two values like this: plus 18 plus or minus square root of 324 minus 288 divided by 2. 2a is 1. You will get 18 plus or minus square root of 36 divided by 2. R1 is equal to 18 plus or minus 6 divided by 2, or you will get it as 9 plus or minus 3. So either I will have two values, one using plus, one using minus. 9 plus 3 is 12 ohm and 9 minus 3 is 6 ohm. So R1, resistor R1, either it can have a value of 12 ohm or 6 ohm, and both are valid answers, isn't it? So if you choose R1 as a 12 ohm, then what happens? The R2 value becomes 6 ohm. If you substitute in R1 plus R2 is equal to 18, and if you choose the R1 value as 12, then R2 will become 18 minus 12, that is 6 ohm. And if you choose the R1 value as a 6 ohm, the R2 value will become 12 ohm. That is how the R2 value will change based on R1 value. I hope everybody understood. Good. Okay, Aditya, both Adityas have done. Please try to solve. If there is any problem you are getting, please ask. It will solve others' problem also. Any other questions? Okay, we'll move on to the next problem. This is the second problem. Find the equivalent resistance of the circuit. So here we have a combination of series as well as parallel. You have to find the equivalent resistance of this particular circuit. You can see here there is a parallel combination here, one more parallel combination here. This parallel combination is connected in series with this parallel combination, and that is connected in series with this single resistor with 1.35 ohm, and this whole combination of series thing is connected in parallel with this resistor 5 ohm. How to solve this? We already know how to solve the parallel circuit. First, what you can do is solve this particular combination, parallel combination. What would be the effective resistance of this? If I say it is RAB, okay, what is RAB? RAB is nothing but the equivalent resistance between these two nodes. If I say RAB is the equivalent resistance of this parallel combination, I can write 1 by RAB is equal to 1 by 2 plus 1 by 5 plus 1 by 10. Then you can find what is RAB. And this particular combination is BC. If I say the equivalent resistance of these two is RBC, then 1 divided by RBC is equal to 1 divided by 6 plus 1 by 1 divided by 4. And if you solve that, you will get the value of RBC. Now you got the value of RAB, RBC, and this one is 1.35. Now if you see, they are connected to end to end. You are going to replace it with one resistor. Whatever the value you are going to find, RAB, you are going to replace with that one resistance. This combination with RBC, and RAB, RBC, and this resistor are connected in series. When they are connected in series, what would be the effective resistance of those three? Sum of the three resistance values, that is RAB plus RBC plus 1.35. Then whatever the value you get, that is connected in parallel with 5 ohm. R is equal to 2.5. Did anybody get 2.5? I think 2.5 ohm is correct. when a circuit is given like that, you have to make sure that you have to identify the parallel, replace them with the effective resistance, and keep on doing that. That is how you should simplify the circuit. 2.55. Okay, let us see. Every time you attend the basic electrical, please keep a calculator ready, notebook ready. So we'll be solving the problems. Vaishnavi got 2.5, Giridhar 2.5. Atiya and Abhi, can you just check? Atiya got 2.5. Okay. Abhi Patankar, can you just check? Is there any mistake in calculation? Okay, many are getting 2.5. Shreyash, good. Kiran, Shrujana. All of you should try. Okay, if you are not able to solve, you should ask questions.
So can you show the problem again once again?
Okay. Shall we look into the solution? Okay. So what I have done is, this is considered as RAB and this is considered as RBC. I will see. Okay. So 1 by RAB is equal to 1 by 2 plus 1 by 5 plus 1 by 10. That is the first parallel combination. That will come as 8 by 10. So this is 1 by RAB is 8 by 10. So RAB is a reciprocal of that. RAB is equal to 10 by 8. Please never miss this one. If you miss this one, if you take this as a 0.8 as a RAB, then all the calculation will go wrong. RAB, you get it as 1.25, and the next parallel combination BC, okay, 1 divided by RBC is equal to 1 by 6 plus 1 by 4. That will come as 10 by 24, and if you reciprocate that one, RBC is equal to 24 by 10, you get it as 2.4. And third resistance is 1.35 ohm. Now this RAB, RBC and the third resistance, they are connected in series. So what would be the equivalent resistance of that series combination of second branch? RS is equal to RAB plus RBC plus RCD. That is, you will get it as 1.25 plus 2.4 plus 1.35. You will get it as 5 ohm. Now on the top there is a 5 ohm, and at the bottom there is another 5 ohm. Two 5 ohm resistances are connected in parallel. So this whole thing got reduced to just 5 ohm. It is connected in parallel with the 5 ohm. Therefore RAD, effective resistance, is equal to 1 by 5 plus 1 by 5. That is 2 by 5. This is reciprocal. RAD is equal to 5 by 2, that is 2.5. Or you can use that technique, RP is equal to R by N. What is RP? The effective resistance is equal to 5 divided by number of resistors 2. 5 divided by 2, 2.5. That is how you will get. Any questions you can ask? Okay. Abhi, you need any help? You can speak out if there is anything you are not able to understand. Answer is 2.5 is the correct answer. 100. Okay, now can you find the equivalent resistance of this particular circuit? We have 3 ohm, 3 ohm, 3 ohm connected in this fashion. One hint here is like, just you have to redraw the circuit to understand how actually they are connected. And I told you when you use the conductors, whenever it connects 2 points, both the points will be at the same potential. You note down this diagram and try to redraw, then you will understand. 0.5. Sir, no, nothing will get cancelled. A mole 0.666. No, that is not the answer. Okay, the hint here is you see this particular line. So this is nothing but a conductor. They are using it to just to confuse you. So you can the potential of this point and the potential of this point is exactly the same. Does current will flow through in this conductor? Hello. If two nodes are there and potential is exactly the same, if we connect those 2 points with the conductor, will current will flow in that particular conductor? Yes or no? This is 5 volt, this is 5 volt. I am connecting with the one conductor. Will the current flow through that conductor?
No, sir.
No. The reason is, in order for current to flow, there should be a potential difference. So technically, this point, okay, I already showed the answer. Okay. This point and this point are exactly the same. If you redraw, you can just remove this conductor and connect this dot to this particular dot to this dot. You can remove. So in effect, what happens? This 3 ohm and this 3 ohm, they look like in parallel, isn't it? Similarly, the potential at this point and potential at this point are exactly the same. Current will not flow. It is as good as this point and this point are exactly the same. Just you remove this conductor and rotate this conductor and join to the point C. Now you can see there are 3 resistors which are connected in parallel. So this will be just assume that there is this line has been removed and this resistor is rotated and joined to this point, and this line is removed, this particular resistor is rotated and joined to point C. Now you will see 3 resistors that are connected in series. This is how it will look like. Everybody understood? If we redraw the circuit as A and D one node, B and D as one node. Okay, this A and D as one node and B and C as one node. So all the resistors are connected between these 2 points, these 2 nodes. So A and D, this is how it will look like B and C. Now once you know these are connected in parallel, either you can use R divided by N, or you can calculate this way. You will get the answer as 1. Is there any doubt here? Okay. Okay, good. Okay, next one. Note down the problem. We have a 100-watt 250-volt lamp is connected in parallel with an unknown resistance R across 250-volt supply. The total power dissipated in the circuit is 1100 watt. Find the value of resistance. Assume resistance of lamp is constant. Okay. So first thing, we'll understand the problem. There is a one lamp. Okay. This is the specification of the lamp. lamp specification is what? 100 watt and 250 volt. So lamp power consumption is 100 watt and it is works on the 250 volt. That is the lamp specification. And this lamp is connected in parallel with an unknown resistance R. This lamp is connected in parallel with an unknown resistance R across 250 volt supply. This parallel combination is connected to an 250 volt supply. Now what they have given is the total power dissipated in the circuit, means altogether the power dissipated in that particular circuit is 1100 watt. You have to find the value of the resistance and assume resistance of the lamp is constant. The lamp's resistance will not change with the temperature. What you have to find is find the unknown R. First, draw the circuit diagram. Which principle you are going to use here? Out of the parallel features we talked about, which feature or characteristic you can use to solve this problem? Anybody? What is the total power consumed in the circuit? If you remember,
P1 plus
P1 plus P2. In this particular case, there are only two. So P is equal to P1 plus P2. P is the total power consumed in the circuit. P1 is the power consumed in the lamp. P2 is the power consumed in the R. P is given, isn't it? And we know what is the power consumed in the lamp. So we can understand what is the power consumed in the resistance R. Can you solve it? Okay, so I will go to the next here. So this is the first thing is you have to draw the circuit diagram. Okay, once you have the circuit diagram, specify all the given values. What is given? Lamp P1, that is lamp is connected in parallel with the unknown resistance R. Lamp specification 100 watt 250 volt, and both this combination of the parallel circuit is connected across 250 volt supply. Total power is given, P is equal to 1100 watt. Therefore, total power dissipated in each branch, P is equal to P1 plus P2. Let us say P1 is the power dissipated in this and P2 is the power dissipated in this branch. Therefore, P is equal to P1 plus P2, or P2. P2 is this power consumed in the resistance is equal to P1, P minus P1, that is 1100 minus 100, that is 1000 watt. Now we know how much power got consumed in the resistive branch, that is P2. P2 is 1000 watt, and we know the formula. P2 is equal to what? V square by R, and P2 is known, V is known. How much voltage? Voltage is the 250. So therefore R is equal to V square by P, that is 250 square divided by 1000. We get the answer as 625 ohm. Everybody understood this problem? Yes or no?
Yes, sir.
Okay, good. So if there is any question, please ask. I will explain. Okay, next one is this one. Can you calculate the branch currents and the total currents in the below circuit? Okay, so if you see here, this is looks like a very complex circuit. Again, it is the same. If you try to redraw this, then you will come to know what is the exact how it is connected, whether series or parallel. So you would be able to understand. This is 50 volt, and this is the node. We have 10 kilo ohm. This is 25 kilo ohm. This is 5 kilo ohm. Please note down this. What you have to find is a branch current. What is the meaning of branch current? Is I1, I2, and I3. The currents that is flowing through the each of the resistors is the branch current, and total current you have to find. And the total current is equal to I is equal to I1 plus I2 plus I3. Please note down this particular diagram, and then you can solve it. In the next class, we will look into this particular. You have to redraw. You remember that 3 ohm problem, how it was connected. After redrawing, how it became. This is very similar to that particular problem. All right. Okay, we will see the solution for this in the next class.